Okay, so question number 7 is, what is the electron configuration of selenium beyond its noble gas core? Okay, so when writing out the electron configuration, we need to follow certain steps. So the first step is to divide our periodic table into the different orbital sections. So for example, S, P, D, and F. So typically in a chemistry exam, you're given a periodic table, so it's important if you know how to divide it into these orbital sections. So let's look up what that might look like. Okay, so this is the periodic table broken up into the sections. So the S block are the first two columns here, including helium. And the P block is this green section, ranging from boron to the noble gases. The D block are these transition metals. And finally, the F block are the last two rows, the lactanides and actinides. So after dividing your periodic table into the different sections, starting from hydrogen, we move left to right across the periodic table and from there we would write the row number followed by the block letter. And also we show how many electrons we have in each orbital using superscripts. I'll also add as a note for part 2 that when we get to block D, we write the row number -1, and when we get to the F block, we write the row number -2. Okay, so let's look at our example, which I believe was selenium. And they ask for selenium beyond its noble gas core, but it just helps if we write out the full electron configuration and then find out what the noble gas core is, and then we can find out our answer. Okay, so let's find selenium on the periodic table. You can see it's right here, atomic number 21. So starting from hydrogen, I'm going to write the row number, which is 1, and then the block letter, which is S, and then to show how many electrons can be in the s orbital, we use the superscript. So only 2 electrons can fit in an s orbital, so this is the max. So we write 1s2. And you can see that this corresponds to hydrogen and helium's electron configurations. Okay, so on to the next row. We write 2, s, and then 2. Moving over to the p orbital, we're still in row 2. And a p orbital can hold a maximum of 6 electrons. So its superscript will be 6. And then we move on to the next row, which is the 3s orbital. 3s2. and then 3p6, and then we write 4s2, thought this was selenium, but I think it's SC. Selenium's actually here, atomic number 34. So we have to keep on going. 4s2, and then 3d10. And then we're back at 4p. And we just need to count out how many electrons until we get up to our desired element, which is the selenium. So it's 1, 2, 3, 4. So it ends up in 4p4. So this is the full electron configuration of selenium. So if we wanted to write this in the shorthand configuration, we look at the noble gas that comes before selenium, which is argon, and we put the argon in square brackets, like so. And then from there, we continue to write the remaining electron configuration like normal. So argon 4s2, 3d10, and then 4p4. So now if we look at what the question asks, the electron configuration beyond its noble gas core, you can see that it is option C. So sometimes you can write the d orbital having a lower energy than the s orbital, like they did in the question. So they have 3d10, and then 4s2, and then 4p4. So this is because for some transition metals, the d orbital is lower in energy than the 4s orbital. Okay, so let's see what the junior tutor said. Let's write the electron configuration of selenium. They have 1s2, 2s2, 2p6, 3s3. I think they mean 3s2, 3p6, 3d10, yeah, 4s2, and then 4p4. Okay, so they said the noble gas preceding selenium is argon, and they summed up the electron configuration of argon. Again, this should be 3s2. They wrote the shorthand configuration of selenium. Thus, choice C is the configuration. So this solution is correct. And then I'm just going to put in brackets that the s orbitals should only hold a maximum of 2 electrons. So for example, it should be 3s2 instead of 3s3. Okay, so I'm just adding that extra note, but they still got the correct answer and the correct explanation. So this solution is still correct.